In this video, we're going to look at histograms. So histograms are similar to bar charts, but they're also quite different. So bar charts, what we've got are statistical diagrams where we've got frequency on the y-axis and your variable, whatever that is, on the x-axis. And we can draw our bars, and all the bars should be the same width, and they represent frequency. Whereas a histogram, rather than using height to represent frequency, it uses area to represent the frequency. So we give the vertical axis the label of frequency density, where frequency density is the frequency divided by the class width. With a histogram, the bars can all be different widths as well, but the key thing is that on the y-axis, it's frequency density rather than frequency. So let's look at an example on this. So draw a histogram to represent the data below. What we've got is speed and frequency. Now for a histogram, we need frequency density, which is frequency divided by class width. So we need to work out the class width. And we also then need to have a column for frequency density. So the first group is from 0 to 30, so that will have a width of 30. The next is from 30 to 40, which is 10 wide. And then 40 to 50 is also 10 wide. 50 to 60 is 10 wide. 60 to 70 is 10 wide. 70 to 80 is also 10. And then 80 to 120 is 40 wide. And now we do frequency density, which is the frequency divided by class width. So we're going to divide our frequency column by our class width. So 240 divided by 30 is 8. 320 divided by 10 is 32. 500 divided by 10 is 5. 780 divided by 10, sorry, that's 50, is 78. 960 divided by 10 is 96. 820 divided by 10 is 82. And 640 divided by 40 is 16. So we're going to draw this on our axis, and our y-axis is our frequency density. And we need to go up to 96. So we can go up in tens. And we can see that one small square is going to be 2. And on the x-axis is our variable, which is speed. And again, we can use one large square to be 10. And then we draw boxes to represent our bars to represent each frequency density that we're going to be looking at. So we've drawn the bars from the frequency density. So the first one goes up to 8, and it is covering from 0 to 30. Then 30 to 40 and goes up to 32. 40 to 50 and up to 50. 50 to 60 and up to 78. 60 to 70 up to 96. 70 to 80 up to 82. And then 80 to 120, and that goes up to 16. Example 23, Robert sowed some seeds in the greenhouse and measured the heights of the plants for 3 months. The results are shown in the table. Draw a histogram. So we need to work out the class widths. And the first one is 0 to 10, so that's 10 wide. 10 to 30 is 20 wide. 30 to 45 is 15. 45 to 70 is 25. And 70 to 100 is 30. Frequency density, remember, is frequency divided by width. So if we do 4 divided by 10, we get 0.4. 20 divided by 20 is 1. 9 divided by 15 is 0.6. 8 divided by 25 is 0.32. And 15 divided by 30 is 0.5. And so then, in our graph, the y-axis is the frequency density, and the x-axis is our variable, which is height. and we'll label the x-axis starting 0, and we'll go up in tens, and then the frequency density will go up by 0.1s. And now we need to draw our bars. The first one is going to be between 0 and 10, and that's going to go up to 0.4, and then the next one will be 10 to 30, and we'll go up to 1, and 30 to 45, and we'll go up to 0.6, and so on. And there's our histogram drawn for us. Moving on to interpreting histograms then. So if we know that the frequency density is the frequency divided by the width, we can kind of form one of those triangles where frequency density is frequency divided by width. So then if we're wanting to work out the frequency, we would multiply frequency density by width. If we're trying to work out the width, we'd do frequency divided by frequency density. But more often than not, all we're looking for is either frequency density or frequency, which is found by multiplying the density in the area. So in this example, Sam is collecting information about the speeds of travels on the motorway. He takes the sample and uses it to plot a histogram. From the histogram, find the total sample size, the modal class, and estimates of the median and the mean. So for this, I'm going to try and reverse engineer our frequency diagram. So I'm going to do my class widths, and I'm going to do the frequency density. I'm going to do frequencies. So the first class is from 0 to 30. I'm going to say the frequency density is 0.8. The next one is 30 to 50. And the frequency density is 5.8. Then we 50 to 80 with a frequency density of 8.5. And then 80 to 120 with a frequency density of 1.2. So to work out the frequency, remember it's the frequency density by the class width. So the first group is 30 wide, and we'll multiply by 0.8 to get 24. The next group is 30 to 50, so that's 20 wide, and we'll multiply that by 5.8 to get 116. Then we've 50 to 80, which is 30 wide, and we'll multiply 30 and 8.5, so 255. And then finally it's 40 times 1.2, which is going to be 48. And if we add these together, we get the total frequency of 443. So the total sample size is 443. The modal class then is the one with the highest frequency, and we can see that that's the 50 to 80 group, because it has a frequency of 255. Part C then, it's an estimate of the median and the mean. So we work the mean first of all. Mean from a frequency table, we need to do sigma fx over sigma f, so we need to work out the midpoint first of all. And then we can do our fx column. So the midpoint from 0 to 30 is going to be 15, 30 to 50 is 40, 50 to 80 is 65, and 80 to 120 is 100. And we'll multiply our frequencies and our midpoints together to get our fx column. And we get 360, 4,640, 16,575, and 4,800. And these values all add up to 26,375. So an estimate of the mean, which is sigma fx over sigma f, is going to be 26,375 divided by 443, which gives us 59.5. So the mean estimate of the speed is 59.5 miles per hour. Now the median is the n over 2 value. So if we do 443 divided by 2, we get 221.5. So it's the 221.5th term. To find out where that is, we could do a cumulative frequency column. And the cumulative frequency is going to be 24, and then 24 plus 116, which is 140, plus 255, which is 395, and then plus 48 is 443. So the median term is going to lie in this group, the 50 to 80. So what we know is in the first group, we've got 24. In the next group, we've got 116, which takes us up to a total of 140. And what we're looking for is a number in this third bar that will take us up to a total of 221.5. So that means we need a frequency of 81.5. So if we add 140, so all the values up to this point are 140. If we add 81.5 to that, we're going to get 221.5, which is the median term. So that means we want the area of this bar is 81.5. Now we know the height of the bar is 8.5. So that means that 8.5 multiplied by the width of the bar, so this blue bar. So if we do the height times the width, because it's a rectangle, it'll give us 81.5. So if we divide 81.5 by 8.5, we get W to equal 9.59. So that means the width of this bar is 9.59. The bar starts at 50, so therefore our median is going to be 50 plus 9.59, which is 59.59 miles per hour. So when we're trying to find parts of a bar or parts of the histogram, the best way to do it is think about it in terms of area. If we know the frequency, that's the area of the bar, and that's coming from the length by the width. So because the frequency that we needed in this group to get to the median was 81.5, that means the area of this bar is 81.5. We know the height because the frequency density is 8.5. So if we divide the frequency by the height, we'll get the width, which will then tell us how far into the bar we need. So example 25, the histogram shows the weights of letters passing through the post office. Draw a frequency table for this data. Then calculate an estimate of the median and calculate an estimate for the weight of the lightest of the heaviest 50 letters. And then we've got a stratified sample. So this is quite an involved question, and we'll look at how to do that now. So we've got the bare bones of our frequency table. The first group of weights are from 30 to 50, and then we've got 50 to 60, 60 to 80, 80 to 100, and 100 to 135. The frequency densities are 0.8, 2.2, 1.8, 3.2, and 1.6. And the widths of each group, so the first one is 20 wide, then 10, and 20, and 20, and 35. And if we multiply these, we get a frequency of 16, 22, 36, 64, and 56. So we've drawn a frequency table. Part B, calculate an estimate for the median weight. So for the median, let's do our cumulative frequency. So that's going to be 16, plus 22 is 38, plus 36 is 74, plus 64 is 138, plus 56 which is 194. Now the median is the middle one, so that's going to be 194 over 2, which is the 97th term. And the 97th term is going to lie in this fourth group. Okay, so we can look at that and put that information on the bar chart. So we've got 16 in the first group, and then we've 22, which takes us up to a total of 38. And then we've another 36, which takes us up to 74. And what we want then is 97. It's the 97th term. So we need 23 more in this group to give us a total of 97. So I'm going to draw the bar. So we need to find, we know that the area of this bar is 23. We know the height of the bar, so we can work out the width. So area is length times breadth. The area is 23. The height was 3.2 multiplied by the breadth. So if we divide 23 by 3.2, we get the breadth of the bar to be 7.19. Therefore, the median weight is going to be 7.19 more than the lower bound of 80. So it's going to be 87.19 grams. So we know that the median is greater than 80 because that's the lower bound of this bar. We know it's 23 in to give us a cumulative frequency of 97, and that there were 74 up to that point. And then the area is 23. We know the height is 3.2, so dividing the height into the area gives us 7.19, which means that the upper width of this height is going to be 87.19 grams because it's 7.19 above the 80. So part C for an estimate of the lightest of the heaviest of the 50. Well, we know that the total frequency in the last bar is 56, but we're looking for the lightest of the heaviest 50. So we want the area in this bar to be 50. So area is length times breadth. We know that the area is going to be 50. We know the height of the bar to be 1.6. And we need to work out the width or the breadth. So if we divide 50 by 1.6, we get the breadth to be 31.25. So what we know then is that this bar of the blue bit is 31.25 wide. We know the upper value is 135, so to get the lower value, we're going to do 135 minus 31.25, which is going to be 103.75. So 103.75 is an estimate for the weight of the lightest of the 50 heaviest letters. Part D then, a stratified sample of 40 letters that weighed more than 60 grams. So more than 60 grams, so that's everything contained in these three bars, is to be taken. Tell you how many should be taken between 90 and 110. So between 90 and 110 is this part in here. So if we consider the population between 60 to 135, so population between 60 and 135 is 156. So that's found by adding these three frequencies together. If we look at the 90 to 100 part of the sample or the population, what we'll assume is that because this bar starts 80 and goes up to 100, we'll assume that half the values are between 80 and 90 and half the values are between 90 and 100. So in our population, half of 64, so half of the 64 is 32, so we're going to have 32 values divided evenly in each half. So to work out the proportion of the population that's between 90 and 100 is going to be 32 over 156. We multiply that by the sample size of 40, and we get 8.2. So there should be approximately 8.2 in our sample. Now we need to look at the next bit, and we're going from 100 to 110. So that's a width of 10 out of a width of 35. So we're wanting 10 35ths of the population of 56 of that bar. So this bar has a total population of 56. If we assume that the values are spread evenly across this width is 10, so we'll want 10 35ths of the 56. So what we know then is that's going to be 16. So it's going to be 16 of a frequency in here, and then 40 in this part. So we know that 16 out of 156 is the proportion of the population that we're looking at. So 16 out of the full amount. And the sample size is 40, so we do 156 of 40 to get our sample size, which is 4.1. So altogether in our sample we'll have 12.3 or 12 terms in our sample. So in our sample, our stratified sample of 40 letters, 12 of them should lie between 90 and 110.